Hey, hello Anand. Am I audible to you? Anand, you are the only person who has joined. So, can you answer me that am I audible to you? Hear you. Message. Uh, I don't know. Like I can't receive the messages also. Shalish. Shalish, am I audible? Say it again. Hello. 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 Anybody, please reply. Okay. Okay. I think it was just sound was too. Okay. Thank you. So, I'm gonna start the meeting, okay? So, I'm just okay. So, my screen is visible to you, right? No, is it not visible? Is my presentation not visible to you? Okay, just wait a minute. Gosh. Is it visible now? Huh? Like I am presenting right now, like week three probability and statistics. It's not visible. This presentation. Okay. Can anybody else tell me that whether it is visible? Okay. Okay. Uh, okay, actually, so issue is that right now you may know that in Himachal there is a cloud burst and natural disaster. So there is so much internet disconnection. Okay, so that is why actually it is happening because net is too slow and speed and everything. So I'm just trying my best to continue this class, but then I'll just see. Okay. So if you have any issue, just let me know. Yes, yes. Okay, so will it be okay if I switch off my camera? Because then speed will be a bit uh, good. Yes, probably. Will it be okay to you? Okay. So is it now visible? The screen? Uh-huh. Is it now visible to you? Mhm. So now it is visible, right? Okay, so I'm Kamna Mishra. Most probably you know, and I'm from IIT Mandi, and I'm currently doing PhD in statistics, probability and statistics. And we will just start questions. If you have any doubts, you can ask in the middle and right now. Don't have any issue. Okay. So let's just start this first question. I have solved I think a similar question in the last class also. So uh, it is a bit similar because when we want to find that only one is defective or at least one similar kind of thing, then we do take a particular way. So what is given here is that the in a manufacturing process, the probability that a produced item is defective is 0.05, and what we want to find is that what is the probability that out of 9 successively produced item only one is defective. So uh, here what is given, n is given, so n is the number, so it is 9, n equal to 9, and whatsoever I'm writing that is not visible, so I'm telling you if it is okay you can write. Okay, and probability of defective item is 0.05. So probability of item to be not defective, it will be 1 minus 0.05. So it will be 0.95. Okay. So what we want to find is that probability that out of 9 successfully successively produced item, only one is defective. So for one is defective, we will choose 9 C1, and then one is defective, so it will be 0.05 and multiply by 0.95 to the power 9 minus 1. So it's wrong here. It's will be answer will be C, and 9 into 0.95 to the power 8. Okay, is it okay? So can you see what I'm presenting or not? Hello. Okay, so now it is visible to you, right? So, what we need to find here is that what is given. Firstly, we have given the values of x and we have given the values of probability of x is equal to x. So, now what we will do is that we want to find the standard deviation. Uh, yeah, it was there should be eight. There was some mistake. So, right answer will be C. No, C 9 into 0.95 times 0.95 to the power 8 into 0.05. Okay. Okay. Okay, so I'll upload it. Okay, last time I have not uploaded these answers because like I have explained it, but today there is some connection problem, so I'll upload it. So now what we have is that we want to find the standard deviation. Okay, in the next problem, it will show in a minute. I think there is some issues. So what we have is that if we have the values x is equal to 0, 1, 2, 3, 4, 5, and we have probability of x is equal to x given, like if you have discrete, then how do we solve? How do we find the standard deviation? Do you know that? If we have like discrete probability mass functions, so we have some points x and then we have some points probability x is equal to x. Any idea? Yeah, actually that is the definition of probability, right? If we have x and then we have yes, then but then I'm asking you, how do we find the standard deviation? Okay, let's just start from the basic. How do we find the mean of it? If we have the probability and we have the random variable x, then how do we find the probability? Sorry, expectation of x. That is mean of x. Okay, so let me tell you. Expectation of x is what? Summation x px, right? X px. So what do we have? We have the values of x and we have the values of probability of x. So the expectation of x will be xpx summation. So expectation of x will be x. So 0 times 0 and then 1 times 2 upon 11. Then 2 times 3 upon 11. Then 3 times 2 upon 11, then 4 times 4 upon 11, and then last 5 times 20 upon 121. So it will be the expectation of x, right? Right? Is it right? That expectation of x will be summation x px. So it will be 1 times 2 by 11, 2 times 3 by 11, 3 times 2 by 11, plus 4 times 4 by 11, plus 5 times 20 by 121. So that will be expectation x. Now, what variance of x? What we have is that variance of x is expectation of x square minus expectation of x and its whole square. Okay, so now what we have is that variance we want to find. So for that we need to find the expectation of x square also. So expectation of x square, what it will be? It will be simply summation x square px. So here, where we have given the values of x as 1, 2, 3, 4, 5, it will be 1 square times 2 by 11 plus 2 square by 3, 2 square times 3 by 11 plus 3 square times 2 by 11 plus 4 square times 4 by 11 plus 5 square times 20 by 121. So it will be expectation of x square. So once you have found the expectation of x square, you will have the variance of x is equal to expectation of x square minus expectation of x whole square. So then you solve it and you will have the answer. Okay. If it is okay, then what we will do is that standard deviation will be under root of variance of x. So that will be your answer after solving. And I haven't solved it, so I don't know correctly what is the answer. But in the PPT, I will upload it and then I will tick the mark. Okay. Is it okay? So we can move to the next question. Okay, so we will move to the next question, and the next question we have here. Uh, okay, so the next question is similar to the question we have here already, x and px, and there also we need to find the standard deviation. So I'm skipping that question, and we will move to fourth question. Okay. So what is given here is that a random variable x has a discrete uniform distribution on integers 0 through 9. Okay. So the given distribution here is uniform, and it is so it is uniform 0 to 9. So this is the way to represent. If we have the uniform distribution, then we represent it as x follows 0, uniform 0 comma 9. So what we need to find here is that if determine the standard deviation of random variable y is equal to 9x plus 2. So does anybody know how to solve this? Like what is the expectation of x, and what is the variance of x? Because if we know the variance, we can find the standard deviation by taking the its under root. So if we have any random variable x which follows the uniform distribution, then what is its mean? What is the value of its mean? Any idea? Anand, any idea? Yeah, so what it will be? The mean will be, there are a formula for everything. So, like, if you have gone through the classes, you should know the formula. Okay, okay. So, if you don't know, I'm just telling you right now. What is the expectation of x is? It is n plus 1 upon 2. And if you take the expectation of x square, so what is x square? When we replace x by x square, then it means uh, the formula will become n plus 1 to n plus 1 by 6. Like you take, so basically how do we have found that it is n into n plus 1 by 2 divided by n. So how do we take average? So basically think that we have the numbers from 1 to up to 9. So 1 plus 2 plus 3 up to 9. Okay, so what is the average of it? Uniform distribution through 0 to 9 means we have 0 plus 1 plus 2 up to 9. So what do we have? Its summation will be n into n plus 1 by 2. So, and for the average, we will divide by its total number. So, sum is n into n plus 1 by 2, and average will be n into n plus 1 by 2 divided by n. So, it will be ultimately n plus 1 by 2. So, no, it will be 10 numbers. Yes. Yeah. So, okay. So, n plus 1, we have 10 plus 11. What? 4.8. Okay. It will be n plus 1 by 2, so 5.5, I think. Expectation of x. Are you solving it by like summation, like 1 plus 2 plus 3, something like that? Because there is formula for summation, right? So summation formula is that n into n plus 1 upon 2. Uh, uh, no, no, I'm just telling you when you do the summation, what you will do, like 1 plus 2 plus 3 plus up to 9. This is what you are doing. It's okay. So 1 plus 2 3, and then 3 3 6, and 6 and 4 10. Then 10 plus 5 15, 15 and 6 21, and then 21 plus 7 it will be 20 uh, 8, and then 28 plus 8 will be 36, and then 36 plus 9 will be 45. So 45 by 2 it will be 4.5. No, sorry, 40. Yeah. So it will be n into n plus, yeah, 45 by 10. So it will be 4.5, and here we will have, it will be 10 into 11 by 2. So it should be 5.5. Okay. If we divide it by number, it will be 5.5. Yeah, okay. Expectation is 5.5. Distribution it is also 0. Uh, okay, I think when we do the calculation from this type, we take the numbers from 1 to 10, not 0 to 9, right? Yeah. So when we do the calculation by this thing, n into n plus 1 by 2, we do the calculation from 1 to 10, not 0 to 9. So your summation will be 55 then, because 1 to 9, the summation will be 45, and then if you add 10, then it will be 55, and then 55 by 2, it will be 5, sorry, 55 by 10, it will be 5.5. So that will be the expectation. But here we have the integer from 0 to 9. So expectation will be, uh, so that time expectation will be, I think, 9 into 10 by 2. So it will be 4.5. So then the expectation of x, because we have 0 to 9, it will be 9 into 10 divided by 2. So it will be 4.5, right? Now is it okay, Anand? Okay. So here we take the numbers like as 9, because 0 will not contribute to any thing, right? When we have 0, it will be 0 times whatsoever its probability, so it will be 0. So now the expectation of x will be 9 by 2, sorry, 10 by 2. I need n plus 1 by 2. This. And the variance we have is n square minus 1 upon 12. So this is also you may get by n plus 1 to n plus 1 by 6 minus n plus 1 by 2 whole square. So when you solve it, it will be n square minus 1 upon 2 12. These are just the formula for uniform distribution if it is discrete, and if it is continuous, then the formula will change to expectation of x will be uh, b plus a upon 2, and then variance will be b minus a whole square upon 12. Okay. So the way we take the expectation here, or the way we define the uniform distribution here, the expectation of x, we take the number as 0 to 9 as 10. So here it will be 10 upon 2, it will be 5, and the variance of x we will have will be 10 square minus 1 divided by 12, which will be 99 upon 12. So now what we have here is, let me just insert my your slide here. No, no, no. Actually, it's not. No, it is for others also. I just started and I told you that there is some issue in Himachal, and due to the cloud burst, there is like so much internet disconnectivity. So I'm telling you, if you can write it down, if is it is still a problem in my voice? Is my voice still breaking? Uh, Anand, is my voice still breaking? We have this in three parts. So from minus infinity to 0. So for minus infinity to 0 and 1 to infinity it will be 0. So ultimately what we have here is that 0 to 1 k 1 minus x cube is equal to 1, dx is equal to 1. So it will be k and x minus x to the power 4 upon 4 is equal to 1, limit from 0 to 1. K here we will have is 1 minus 1 upon 4, it will be 3 upon 4, so it will be 4 upon 3, right? K will be 4 upon 3. So the fx we have now here is that fx will be 4 upon 3, 1 minus x cube, it will be from 0 to x1 and it will be 0 else. So now we want to find the expectation of x. So expectation of x will be x fx dx. So in the time of discrete, it is summation x fx, and in the time of continuous it is uh, integration 0 to 1 x fx dx. So we will have 0 to 1 x fx is 4 by 3 1 minus x cube dx, right? So it will be x 4 by 3. So 4 by 3 will come out and we will have 0 to 1. Okay, let's just solve it. So x and then x will be x square upon 2, x cube, so x square, and it will be x to the power 5 upon 5. So ultimately we will have 4 by 3, 1 by 2 minus 1 upon 5. So we will have 4 by 3 times 5 minus 2 5 minus 2, 3 by, answer is 4. For what? Expectation of x. Will it be 4? X minus x to the power 4. So I'm not getting the answer as 4. I'm getting it as 2 by 5. Is there anything wrong? Okay, okay. So now, as we want to find the variance of x, we will find the expectation of x square. So it will be 0 to 1 x square, and then 4 by 3, 1 minus x cube dx. Okay. So now what we have is that 4 by 3. So at x square, x cube by 3. So x cube by 3, if we put the limit, it will be 1 by 3. And then x to the power 5, it will be x to the power 6 upon 6. So what it will be 2 minus 1 will be 1 upon 6, right? So it will be 2 upon 9. So variance of x, we will have 2 by 9 minus 2 by 5 whole square. So it will be 2 by 9 minus 4 upon 25, right? So now you can solve it, like I think 25 times 9 will come here, and it will be 9 times 25, so 50. 50 minus 4 times 9, 36. So we will have 14. So we will have 14 divided by 225 as the answer. Is it okay or any doubts? Okay, so we will move to the next question. This is important. So given here is that fx as 1 when it is x is in between 0 to 1, and we have fx is equal to 0 otherwise. So we have given here is that y is equal to minus 2 log x. Just a minute. The time I have solved this, we have found what is x and y. Sorry, what is the expectation of uh, x? So expectation of y will be 9 upon 2 expectation of x. So it will be 9 upon 2 and whatsoever its expectation. You can do that. And for variance also. So for variance, if we have uh, y is equal to ax, then what is the variance of y in terms of variance of x? Okay, so if we have y is equal to x, then expectation of y is a expectation of x. But if we have y is equal to x, then variance of x, y is variance a square variance of x. Okay, because when we change, even if we have y is equal to ax plus b, then also the variance of y will be a square variance of x. Can you tell me the reason why it should be variance of y is equal to a square variance of x? And because like when we take the variance of b, what is the variance of a constant? What is the variance of a constant? It is zero. Okay, because when it's a constant, there is no variation. There is no variation. What we basically try to find that if we have any random variable x, then how much it variate, how much it deviate from its mean or its origin, whatever you want to say. So when it is a constant, that means it is a single point. So at that point of time, the variance is zero. So variance of y will be variance of a square plus x, and then variance of y b is equal to zero. Okay, so let's just move to the question. Okay, so does anybody know that if we want to find the expectation of y, then we can find it from the moment generating function we have mxt as expectation of e to the power dx. Do you have idea of this? No. Okay. So there are two kind to find there are two ways to find the expectation, like mean and then variance, and so many uh, like expectation of x, expectation of x square, x cube, x to the power n. So there is a way to find it. What is it? What it is? It is a moment generating function. Okay. So moment generating function is nothing but expectation of e to the power dx. Okay. So moment generating function, if you have, and then you differentiate it one time, that means if we have dmx t by dt, and then we put 0 at this point, x is sorry, t is equal to 0, then the value we get is mu, which is mean. Okay, now if we differentiate it two times and then again we put 0, then the value we get here is expectation of x square, and similarly for expectation of x cube, and then expectation of x cube, so we will differentiate it three times. So this is the simple way that, say, one time you do the integration for expectation of t to the power x fx dx, what it will be expectation of e to the power tx, that is mxt, will be uh, whatsoever it will be the limit, let us say minus infinity to infinity, it will be expectation of sorry, x e to the power tx fx dx. Okay, so this moment generating function, one time we solve the integration, and then what we do is that we do its differentiation, and one time it will be mean. We do the differentiation two times, it will be expectation of x square. Three times it will be expectation of x cube. So this is a way to find, another way to find the expectation of x and x square. And this is what we will use here. You can use the another method also, the direct way, but I will try to solve it with this. Okay, so let me just insert one more slide. So what we have here is that fx we have. Now we want to find the expectation of ty, e to the power ty, because what we need to find here is that we want to find the expectation of y. So expectation of y will be dmxt by dt, right? So it will be expectation of ty, and mxt, sorry, myt, it will be expectation of ty, and it will be 0 to 1. Now we have y values in terms of x, so we will write it in that way also only. So it will be expect e to the power t, y is minus 2 log x, and since we have the variable in terms of x, we will do dx here, right? So can you solve this integration? It's not difficult. can you try to solve this integration, and then I'll give you 2 minutes, and after that I'll solve it. Uh, uh, are you able to solve it, or otherwise I'll solve it? Okay, so I'll just give you a hint. What we do here is that we will take this in power. So x e to the power exponential t, e to the power minus 2t log x. What we can write it as e to the power log x, and it will be minus 2t dx. Now what we have here is that if we have e to the power log x, then it will be simply x. This is the like formula. So if we have expectation of log x, it is simply x. Uh, so it will be simply x. So it will be 0 to 1, x to the power minus 2t and dx. Now you have it as x to the power n, and then what is the formula for x to the power n dx? Integration x to the power n dx. What is the formula for x to the power n dx? Okay, it is x to the power n plus 1 divided by n plus 1. These are just, I think, very basic formula you should know. So it will be x to the power minus 2t plus 1 divided by minus 2t plus 1 from 0 to 1, right? So it will be ultimately 1 upon 1 minus 2t. Is it clear up to that? Is it clear to you? I'm audible to you, right? Okay, and is it clear? See, if okay, how did this tx disappear? Last, this one? Yeah, it. If you put the value in place of x, okay, so 1 to the power this one will be 1. Okay, okay, okay. So you have this now. we want to find the expectation of x. What is expectation of x? It will be m by t divide differentiation with respect to t. Okay, so expectation of y will nothing but uh, differentiation of m by t divide with respect to t, and put t is equal to 0 in that. So it will be uh, 1 upon 1 minus 2t. So its differentiation will be 1 minus 1 upon 1 minus 2t whole square, and for minus 2t it will be minus 2. So simply it will be 2 upon 1 minus 2t whole square. And now if you put t is equal to 0 in that, it will be 2. Right? So it will be a 2, and now the second, so it will be from either a or it will be either d. Now we want to find the median. So what is the median? It is the point. Okay, if you have any kind of distribution, then median is the point where fx is half, capital Fx. That means it has already completed the half of its area, and half of its area is remain. So what it mean? It is the point 0 to m fx dx should be half. So m is the point where this is what, this will be fm, right? So m is a point at which the probability density function has completed its area as half of its area. So it will be 0 to m fx dx 1 by 2. Now we want to find that point m. So now we have probability y less than or equal to m. Now y less than or equal to m, what we can do is that we can write the y in terms of x, uh, or we can write x in terms of y. So x is y is minus 2 log x. So x will be y by 2 minus, it will be, so it will be e to the power minus y upon, right? So we can write expectation of probability that x less than or equal to m will be probability x less than minus e to the power m upon 2. So basically we need to find this probability. Now in terms of x, it will be very easy. It will be 0 to up to e to the power minus m upon 2 fx dx. Now what is fx? Fx is 0 when x is in between 0 to 1 and 0 otherwise. So if you see the graph, it is 0, uh, sorry, it is 0 here, and 1 here, and then again 0 here, right? Something like that. So f median will be in between here. So now it will be 1 dx is equal to half. This is the formula, 0 to m, because we are taking for y, so it will be 0 to e to the power minus m by 2 1 dx. Now for 1 it will be x, and when we put this 0 it will be 0 to it. So ultimately e to the power minus m upon 2 will be 1 upon 2. So what we have here is that minus m upon 2 will be uh, log 1 upon 2 log e, right? Log e 1 upon 2 will be minus log e2. So at last we will have minus m upon 2 will be minus log e2. So minus minus will be cancelled out, and at last we will have answer as minus 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 will be cancelled out, so 2 will go there and it will be m is equal to 2 log e. This will be the answer. Any doubts? Any doubts? Okay, so if no, then we will move to the next question. So the next question given here is that we have given x is a continuous random variable with the probability density function given as fx, and we have given expectation of x. So basically we have given two equations and then two variable a and b. So firstly we will find this variables a and b, what is a and b, and then we, after getting a and b, we can find the median of x. So the second equation we will have from expectation of x, and how we will get the first equation in terms of a and b. How we will get it? It will be like minus infinity to infinity fx dx is equal to 1, right? So we have that condition. So we will put uh, minus 2 to 0 ax dx plus 0 to 2 bx dx is equal to 1, right? Because minus infinity to minus 2 fx dx will be 0, and 2 to infinity fx dx will be also 0. So in total what we have here, that will be 1. So a, and then x square upon 2 plus b x square upon 2. Limit here is that minus 2 to 0, and here is 0 to 2. So it will be 1. So if we solve it, it will be minus 2a plus 2b is equal to 1. Simply minus a plus b is equal to 1 upon. This is the first equation we have. Now for the expectation of x, what we have here is that x fx dx. So it will be minus 2 to 0 a x square dx plus 0 to 2 bx square dx is equal to 1. So it will be ax cube bx cube, and if you will put here is, it will be minus, so x cube, it will be 8 x cube upon 3, so it will be 8 upon 3 a plus 8 upon 3 b, sorry, it will be 4 upon 3. 3. It will be 4 upon 3. So we will have 2a plus 2b is equal to 1. So 8 by 3, 8 by 3, 4 by 3 will be cancelled out. So we will have the equation for that is 2a plus 2b is equal to 1. So one equation we have minus 2a plus 2b is equal to 1, and one equation we have 2a plus 2b is equal to 1. So ultimately a will be 0 here and b will be half if you solve these equations, right? Is it okay? So now we have fx as a is equal to 0, so it will also be 0. So we will have it as x upon 2 when x is in between 0 to 2, and otherwise it is 0. So now the problem is very simple. We need to find the median, and for median it will be 0 to m fx dx. So it will be, sorry, x by 2 dx, it should be half, because at the medium it has completed the half of its area. So it will be x square upon 2, which will be m square upon 2. So m square upon 2 into 2 because 2 is already there. So it will be 1 upon 2. So m square will be 2 and m is equal to root 2. Okay, so can you tell me why we have not taken minus root 2 point as median? Any idea why we have not taken minus root 2 here as the median point? It's simple because it does not lie in between the range of x. When we have the range of x is 0 to 2, the median cannot be minus root 2, right? And also you can just take that if m is equal to minus root 2, then at that point it will be minus root 2 upon 2, which is not possible. Uh, so it will be root 2 will be the answer. Now move to the next question. Uh, the previous question was clear to all of you, right? So if you will not say anything, then I am considering it as yes. Okay. So next question we have here is that a fair dice is tossed 3,000 times, and the tosses are being independent of each other, and we need to use the Chebyshev inequality to find a lower bound for the probability that the number of ones observed in between 470 and 530. So I have already told you in the last class the Chebyshev inequality is that this is less than equal to k is greater than or equal to 1 minus sigma square upon k square. So we want to find the lower bound. So lower bound will be 1 minus sigma square upon k square. Now to find that lower bound, we need mu, we need sigma square, and we need k. Okay. So expectation of x. What is x here is that number of ones observed. It's, so what we have here is that expectation of x. Uh, so expectation of x we will have here is that once observed, so it will be 1 by 6 for 1, and it is 3,000 times, so it will be multiplied by 3,000. So it will be 500. So expectation of x is 500. Now we need to find the sigma square. Sigma square means variance of x. So variance of x is expectation of x square minus expectation of x. So expectation of x square will also be 1 by 6 here, and this one is 1 upon 36. Sorry, expectation of x whole square. So it will be 36. 6 times 6, 6 minus 1. It will be 5 upon 36. Right? So variance of x we have as 5 upon 36. Uh, so we have variance of x when it is 3,000 times. 3,000 times. It will be n sigma square. Yes. 1 by 6, like if you have a fair dice, then what is the probability of 1 and then 2 and then okay, so 1. Yes, so yeah, so for 1 observed we have 1 by 6. Okay, for 2 observed it will so okay. And yeah, you should not be sorry for what you don't know. Okay, you can just ask simply. I'm here for that only. So variance of x for 3,000 time it will be sigma square n. Okay. So n will be n is 3,000. So 3,000 times 5 divided by 36. So it will be uh, you can solve it by 6. It will be 6 and then 500. Okay, and then 2. So it will be 250. It will be 3. It will be 250. So it will not cut anymore, I think. So 250 times 5 is 25, 50, 50, 75, 125. So it will be 1250 by 3. So variance of x we will have as 1250 upon 3, and expectation of x we have is 500. So now I have told you in the last class how to find k. So k is basically the number we find like x minus mu less than or equal to k. So you can either 500 minus 470, it will be k, or you it is same as 530 minus 500. So anyway you can find it because it is in the middle only. Like mean will always be in the middle, and k will be like uh, in left and right, whatsoever in left and right range or limit, whatever you want to say. So k will be 30. So basically we have the question as x minus 500, and it is less than or equal to 30. Okay, so now if you observe it, it is nothing but x is in between 470 to 30, 530. So this is how we have made this question. So we need now we want to find its probability, the number of ones observed between 470 to 30. So probability of 470 to x 30 will be, and we need to find its lower bound. So lower bound is 1 minus sigma square upon k square. Now you know the sigma, now you have the k. So it will be 1 minus sigma square is 1250 divided by 3, and k square is 30 square. And then you can solve it and you can find the answer. Right? So after solving, the value you will get uh, is 0.537. If you will not get it, you can ask me again in the next class, or you may write in your form. So, but like the basic is clear, right? Yes. Yeah, because we have expectation of x is 500. So this is the formula for Chebyshev inequality. This is the formula. So what we have is here is x minus 500 less than or equal to and 30. So 30 we have k. Okay. Uh, Expectation of x is 500, and the k we will get here is that 500 minus 470 or 530 minus 500. Okay. Anyway. Okay, so next question we have here is that MXT. Okay, so this is you have solved the question similarly. We need to find the variance of x. So variance of x, how you find is that expectation of x will be firstly MXT uh, d by mxt dt, and t is equal to 0, and expectation of x square you will find in the similar way d of mx t d2 dmx dt2, t is equal to 0, and the variance of x will be expectation of x square minus expectation of x whole square, right? So these are main formulas. So these are formula. So firstly, we will find the expectation of x. So expectation of x first. we will do the differentiation mxt. So mxt here is e to the power t. Let me just write it. Mxt is e to the power t divided by 3 minus t. So if you differentiate it, it will be 3 minus 2 e to the power t whole square. Expectation of t. Uh, sorry. It will be 3 minus 2 e to the power t whole square. Uh, 3 minus 2 e to the power t, e to the power t, e to the power minus uh, e to the power t. 3 minus e to the power t will be minus 2 e to the power t. So it will be 3 minus 2 e to the power t whole square, and this will cancel out, so it will be 3 e to the power t. So expectation of x will be at t is equal to 0. So it will be 3, t is equal to 0, it will be 3 minus 2 whole square. So it will be 3. Right? Sorry. So now next we will find the expectation of x square. Right? So expectation of x square, what it will be? It will be we have expectation of x, so this is d mxt by dt. So now we need to differentiate it again. So to differentiate it again, you can either take it as a first function, second function. So you can take upper portion as a first function and lower denominator part as a second function. So you can do first and then leave the first and do the differentiation of second function, plus leave the second one and do the differentiation of first function. Or you can do it like uh, or we do by numerator and denominator, the differentiation as the denominator is square and something like that, like I did in this. So I'm doing it by that only. So it will be 3 minus, it is a square, so it will be 4. And then we will have 3 minus 2 e to the power t whole square, and then 3 e to the power t will be 3 to the power t minus 3 e to the power t. And for this we will have uh, 2 times, like take it as x to the x square, so it will be 2x, right? So it will be 2, 3 minus 2 e to the power t, and for minus 2 e to the power t it will be minus 2 e to the power t. Other thing is 0. I am so sorry, this is so clumsy. Just uh, write it in your copy, it will be clear. So at that point, this point only, I'm putting the values of t as 0. So if you put it here, it will be 1. It, this will be 3 minus 3 times 2, and then 3 minus 2 e to the power t will be 3 minus 2, it will be 1, and minus 2 e to the power t will be minus 2. And here we will have 3 minus 2 whole to the power 4. So it will be 3 plus 3 times 2 times 2, so 3 times 6, and 6 plus 2, 12, right? Divided by 1, so it is 15. So now the variance of x you will have will be 15 minus 3 square, x expectation square, so it will be 15 minus 9, which will be ultimately 6, right? Any doubts? Okay, so no doubt, then we will move to the next question. And so next question given here is that a random point P is taken on a line segment AB of length 2A. See this A, B. What is the find the expected value of maximum of AP plus PP? So okay, this is a very general question. If you have any, if you have any line, let's say length L or let's say length 2A, and we need a point P so that it divides it in the expected value will be the maximum or area will be the maximum or whatsoever we take, then what it's like, what it that point, like what will be the length of this and this. Okay, so generally means if we have any line and we want to divide it in such a way that the expected value is maximum or the area is maximum, then it always then P is always the midpoint of that line. So this is you can solve it also, but this you can like remember it. It will be better if you remember it. This is always the midpoint. So when it is the midpoint and we want to find the expected value, so let's just say the random variable as x is 1 and 2. So the point for AP, its distance will be A, right? And for this also it will be A. So if expected value will be A plus B upon 2, as this is a continuous function, and you can write it as A plus 2A upon 2, so it will be 3A upon. So this will be the answer. Okay. So next we have the question here is that an electronic store has 20 TV sets. Okay, 20 TV sets, and five of these have some manufacturing defect, and a customer randomly selects 4 TV sets, and we need to find the probability that the simple sample will have exactly one defective. Now, if you have any question like this, then it it is called that this follows the hypergeometric distribution. So in hypergeometric distribution, what you have is that you have this 20 sets, and then five of these are manufacturing, have some manufacturing defects. So you can take 5, 15, and 5. So these are non-defective and these are the defective ones. Okay. Now we want to find the probability that the sample will have exactly one defective. Exactly one defective means we have chosen one from this and three from this. So probability that exactly one defective will be it will be 15 C1, 5 C1, and overall we are choosing 15 C3, 5 C1, and overall we are choosing uh, 4 TV sets out of 15. So it will be 20 C4. So now when you will solve it, it will be 0.469, something like that. So is it clear to everyone? Okay. So next we have here is that x follows a binomial distribution with mean 8 and standard deviation 2. So now we have x binomial n comma p. Let's say okay. So binomial n comma p we have. Now we need to find the n and we need to find the p. So for binomial distribution, we have given here expectation of x and variance of x, which is a standard deviation x square as 4 and it is 8. So do you know the formula of mean and variance of binomial distribution? Okay, have you done the classes like sir has taught, Somesh sir, about the distribution, discrete distribution, and uniform distribution? And yeah, it is NP and NPQ, or NP times 1 minus P. Okay. So expectation is NP, which is 8, and variance is NPQ, or you can say NP 1 minus P, it is 4. So NP, we can find here is 1 minus P is Q basically. So if you divide this, it will 1 minus P will be 1 upon 2. If you divide by this, it will be 1 minus P will be 1 upon 2. So P will automatically be 2. Now it is NP, so P will be 16. Sorry, N will be 16 as P is 1 upon 2. So we have found that our X follows binomial uh, 16 comma P is half. So this is we have now we need to find probability of x greater than or equal to 3. So x greater than equal to 3 is x minus x is equal to 0, x is equal to 1, and x is equal to 2. So for x is equal to 0, it will be 16 c0, 1 by 2 to the power 16, right? So for and then 16 c1, then also it will be 1 by 2 to the power 16, because for p and 1 minus p values are same. So it will be 1 by 2 to the power 16 and 16 c2, and so on. So if you will solve it, it will be 0.9979. So this will be the answer. Okay, is it clear? Okay. So, next question what we have here is that since not all airline passengers show up at their for their reserved seat, and airline sells 120 tickets for a flight that can accommodate only 120 passengers. So what we have here is that, yeah, we have a flight and there are only 120 seats, but we sell the tickets for 122 passengers because not everyone come at that point, right? So, and the probability that a passenger does not show up is zero point 0.1, and the passengers behave independently. So what is the probability that every passenger who shows up can take the flight? So what does that mean? It means that if a person came at that point, then the person get the seat. So it means that the number of person came at that point of time, that should be less than 120, right? If you have 120 seats and 122 all the people came, then it will not everybody will get the seat. So uh, the probability that every passenger shows up can take the flight will be, that means the x needs to be less than 120. So if you have x is equal to 100, then that means 100% will get, all the 100% will get the seat. So for x less than 120, it will be 1 minus probability that x is equal to 121 minus probability that x is equal to 122. So it will be 1 minus, and now for 121 and 122, we have 122, 121, and uh, zero point 0.9 to the power 121 and zero point 0.1 to the power 1, right? And this one will be 122, 122 and zero point 0.9 to the power 122. So when you will solve it, this is a very small number, 0.3807. So it will be almost 0.9999. So there are 99.99 chances that all the passengers shows up will take the flight. Okay. Okay. So we will move to the next question. The question given here is that a large car has car showroom has 1,000 car on display, and it is known that the 50 cars have some defect, right? And if the quality inspector checks randomly the 20 cars, what is its mean and variance of the number of cars found defective during the inspection? Again, we have 1,000 cars and we have some defectives, and we are checking randomly sub cars. So again, this is hypergeometric distribution. Now it is very important when you solve the question to understand what is its distribution, because otherwise you may end up solving it like in maybe in a wrong way or maybe in a very very lengthy way. Because when you know it is hypergeometric distribution, you can just put the value, sorry, you can just put the formula for mean and variance, and then you can find it. So I'll tell you, since we have not gone through all this. So a hypergeometric distribution we have. So capital N we have as 1,000, okay, and K we have here as 50, and a small n we have here as 20. Right? So for hypergeometric distribution, the mean formula for mean is nk upon n, and the variance is nk upon n, 1 minus k upon n. That means basically, if you say it is like np and then npq, and it will be n minus n divided by n minus 1. So you can just put the values. So it will be 20 times 50 divided by 1,000, right? It will be 1. And similarly you can put the values here is that 50 times 20 divided by 1000, and then you have 1 minus 50 divided by 1000, and n minus m, so 1000 minus 20, it will be 980 divided by 999. So when you will solve it, it will be something uh, 0.93193. So it will be 0.932. So this will be the answer, right? Okay. So we have three questions left. Now, suppose what we have here is that fx to be a PDF of form fx is equal to k e to the power minus half mod x minus 2, and x is in between minus infinity to infinity, and we need to find the value of k. So this is simple. What is important here is that dealing with the modulus sign, right? So we have fx is equal to k e to the power minus half mod x minus 2 minus infinity to x infinity. So we will have it as uh, k e to the power minus half x minus 2 uh, minus when x is in less than 2, because x minus 2 will break at 2, right? At x is equal to 2 it will break, so for x it will be something like that, x minus 2, right? And when we have x from 2 to infinity, it will be k e to the power minus half x minus 2. So this is the expanded form of fx. So fx, now we know that minus infinity to infinity fx dx is equal to 1. So now we can solve it, and then it will be minus infinity to 2 k e to the power minus minus will cancel out half x minus 2 dx plus 2 to infinity k e to the power half x minus 2 dx, and this will be equal to 1. So this is also not a different integration. You can do this. So just try it on your own. Otherwise, I will solve it. I'm presenting this. This is integration. E to the power x. So e to the power ax will be e to the power ax integration will be either you can take 1 by 2 x minus 2 is equal to t, and then you can solve it, or either you can just do it as e to the power ax as uh, e to the power ax upon a. So in that form also you can do this. So in any form you can just try, and I'll take I'll give you 3 minutes time for this integration. Otherwise I'll solve. Okay, has anybody solved it? Or like if you are trying to solve, then which way you are using? Okay, so I will solve it. So uh, let's just take it as we can take it as 1 by 2 x minus 2 s t for the first one. Uh, and for the second one also we can take it this, and then we can have the change of limit. So 1 by 2 x minus 2 will be 1 by 2, uh, for x it will be 1 by 2 dx is equal to dt. So basically dx will be dt. So when x is equal to, so for the first part, when x is equal to minus infinity, t will be minus infinity, and when x is equal to 2, t will be 0, right? When x is equal to t, 2, t will be 0. And for the second part, when we have uh, x is equal to 2, it will be 0, and for infinity, it will be infinity. So the problem we will have will be minus infinity to 2 e to the power t dt times 2 plus uh, minus infinity to 0, it will be 0, right? And it will be 0 to infinity e to the power minus t 2t dt, and that one will be equal to 1 times k. So k we can take as common. So e to the power t differentiation, integration is e to the power t. So when e to the power t, e to the power 0 will be 1, and then e to the power in minus infinity will be 0. So for this part it will be 2 plus e to the power minus t. So e to the power minus t upon minus 1, it- and limit will be from 0 to infinity. So it will be k 2 plus 2, and at minus infinity it will be 0, and uh, at 0 it will be 1. So 2 to 2 4. So we will have 4k is equal to 1. So k is equal to 1 upon, so 1 upon 4 will be the answer, right? So next question we have here is that in a clinical study, volunteers are tested for a gene that has been found to increase the risk for a disease. So there is a gene, and it increases the risk. For any disease, it increases the risk, and the probability that okay, uh, so the probability that a person carries a gene is 0.15, and we need to find the probability that four or more people will have to be tested before two with a gene are detected. So this question is based on the a distribution named as negative binomial distribution. Negative binomial distribution. So x is the number of tests before two with x is the number of people, that means four or more will have to be tested before the two genes are selected. So we have x as the number of tests before with genes are detected, right? So we have x here, and then we need to find the probability 4 or more people. So we have this probability as f of 4, and it its formula is that n minus this, let us say this as capital N and 2 as a small n. So the formula here is n minus 1, n minus 1. The person carries his gene. This will be 1 minus, let's say, p, and its power n minus small n, and p with the power small. So you will have f of 4 as 4 minus 1, 2 minus 1, 1 minus 0.15 to the power 2, and 0.85 to the power 2. So when you will solve it, it will be something like 0.48. So answer will be 0.4876. Uh, if you have doubt in questions like this, then it will be better if you go through all the distributions like Sarah has discussed. And still, if you will have the problem, then like I will give a brief review about the distributions. Today is so much disturbance, and that's why I haven't discussed each one of them. Otherwise, I will go through all the distribution once uh, for like half an hour to 1 hour, so it will be clear to you. And the last question we have here is that assume that each of your call to a popular radio station has a probability of 0.03 of connecting, because sometimes the signal is busy and sometimes you cannot connect to your call, and assuming that your calls are independent, then we need to find the what is the mean number of calls that needed to connect. So again we have this distribution as x as sorry geometric distribution, access geometric distribution with uh, lambda. So x, whenever x follows geometric distribution, we call it as a lambda, and it's mean because we need to find the mean. So expectation of x is 1 upon, so it will be 1 upon 0.03. So which means it will be 100 upon 3. Okay, so 100 upon 3 will be the answer. Okay, so if you have any doubts, you can ask me, and if you don't have any doubts, then like have you solved the assignments? Uh, and you have any doubts in assignment solutions or problem, then also you can ask, or regarding the lectures whatsoever. Because like maximum I can do is that uh, I can think of some questions which I think is important or maybe difficult to you, but you can think of in a better way. I think that uh, what you can understand and what you cannot understand, so you can ask me in that class. And this is I have left this question because this is similar to this problem, and you can solve it on your own. Any doubts, Anna? Uh, uh, yeah, yeah. Okay, okay. Thank you. Okay. So, you can leave the call.